Good morning, everybody. Thanks for coming along. Good morning, Peter, Sion. Yes, good mukmu to Sion. And there are lots of people. I'm not going to go back and say hello to everybody. Right, I did notice there were a couple of comments. Oh, and also before I get into this, I almost forgot. I acknowledge the traditional owners of this land. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, there are a couple of comments back there in relation to the 32 port I/O board. Yes, it's a lot of soldering, and yes, I need a bigger ultrasonic cleaner. We'll get to that. And I see that Chip is out at the racetrack today. So is the event today at the Ballarat Light Car Club? So it's the motocross event. Sounds like a lot of fun. Okay, where are we? Costas, good morning from Greece. So, because I started 2 minutes late, Peter has now just given me the warning. 118 minutes. I've already burned 2 minutes of my allocated 120 before he becomes the lunch police and starts telling me to get in. Cable tie, you're in Wartook. Oh, yes. Look it up. Yeah, I know where Wartook is, but I bet a lot of people don't. So, okay. Where am I? What am I doing? What are we doing this morning? I have no idea. I did have a plan. I did have a plan. I've actually got a few things to talk about today, and I don't know if we'll get to them all. We probably won't. We probably won't even get through the first thing. Now, I was actually just thinking, last week I was talking about the paving and things that we were doing outside. So I was just thinking, I'm just on my phone, I'm going to pull up DroidCam so we can go all mobile again. Because yesterday we moved some... Hang on, here we go. Where am I? I've got to switch my stream. Before I get into other things, we'll go for a little walk out the back and see an update. Portable camera, is this working? Audio is coming through, but no, we are not getting... Oh yes, we do. We are. We have the portable camera. I'm going to try walking slowly once again so I don't make you seasick. So, going past Monitor City and the pick and place machine. And let's go for a little walk out this way. Head out the back door. Oh, it's like Casey hand cam. Out the back door, because yesterday we moved another 3 cubic meters of crushed rock, which was once again a whole lot of wheelbarrows. So the area here has now been compacted. So there was so Peter, our gardener landscaper, came in yesterday and he used one of those vibrating things that packs down the rock. And at the first layer it was all compacted, and then we brought around another 3 cubic meters of crushed rock. We wheelbarrowed it around the back of the house and laid that down, and then that was all compacted. So we've got a really solid bed there now. Next thing to do is there's going to be some sand that will go over that for the final level, and then the paving will be laid. But I put a few pavers down yesterday because we're looking at the pattern, and just down there somewhere you can see a little bit of conduit coming out of the ground. There's a draw lead and there's a cable coming out of it, and that goes down under the crushed rock into the ground all the way across, and it comes up under the house there, and then it's subtle clamped to the frame. You can't really see that. It's way down and way underneath. Anyway, we won't get back into that topic today. I've got those lights on order, the ones, I think it was Austin who recommended them. And so what we've been trying to figure out is the pattern for the paving. These are bluestone, like a bluestone concrete hybrid paver. It's crushed bluestone set in cement and then polished, like all cut flat. So they're really, really heavy and very cool. So they're square. I think about 400. I think they're 400 millimeters square. So we've been looking at whether we should align them this way, with the pattern coming out perpendicular to the house, or whether they should be diagonal. And it's a little bit hard to tell from this pattern, and also we've got the shadow of the tree over it. But I think I need to put some more out there to get a better idea of how this pattern works. But I actually really like the diagonal pattern. It looks quite cool when you're standing at the right angle. So there would be a whole lot of triangles to cut. Lots and lots of cuts if we do it that way versus if we do it that way. So originally I liked this pattern and I thought the straight one was kind of boring. But now I really like the look of the straight one. And this is all going to have red brick edging all the way around it as well. So it'll be a red brick edge and then bluestone paving in the middle. And then there'll be some edging around the tree garden bed thing there with the lights concealed down there shining up into the tree. Anyway, a little bit of a status report. So that was about a month's worth of exercise that I got yesterday, moving crushed gravel, crushed rock. All right, back into here. All my Yamaha feeders are still sitting here waiting to get into the factory so we can set up the pick and place machine. And the lab is a mess. I hate working in it when it's all messy like this. My brain doesn't handle it at all. So when when things like this happen, and the central bench is all just stuff piled up on it and things shoved aside, you know that it hasn't been a good time. I've been frantic trying to get stuff done, and that gets out of control and disorganized like this. These bags are all parts related to the Rockling, which is the FPGA board with the Theremin front end on it. I've got to assemble a heap more of those. There's some stuff here. This is for a PCB conveyor project that I'm working on. Anyway, more about that another time. And hello, Steve. Okay, back down to here and back to front camera. I'll get out of Droid Cam. Where are we? Cable Tie says, I stopped mid-bike for an ice cream. I just looked at the chat and that was randomly the thing I saw. Thanks for making me want ice cream. Yes, motion sickness alert. Right. Yeah. Sion says, I like the diagonal. You can look at them from different angles and it's less jarring. Yeah. Before we did the, before yesterday, in between yesterday and when the first lot went on, I laid down a really big area of the diagonal, and I'm just wondering if I can show it to you through the CCTV camera. I could, but I won't. I only lay the diagonal, and I did a bigger area than that. It was only yesterday after the rock was compacted that I ended up laying out the straight version and the diagonal version. So the diagonal version that's there now is smaller than it was before. And when it was bigger with more of the pavers, it seemed more cohesive. You need more of it to get a sense of the pattern because it's more visually confusing. And it looks cool from different angles. So from one angle you get the straight lines running along it, and from the other angle you get like the staircase effect. Anyway. Right. Chip, you're back. So you caught up. All right. Jack's Tech says herringbone. So these pavers are square. So I was joking about doing a herringbone, or if we just laid them all side by side in a grid, then we could just tell everybody that it's herringbone. Every second one is rotated 90 degrees and you just can't tell. But with square pavers, it actually limits you a fair bit in terms of what you can do. And it can't be just, unless it's on a concrete base, which is, this is not going to be. It's crushed rock and then sand and then the pavers on it. If it's on concrete, you can do whatever pattern you like without worrying about the structure of it. But for going onto sand, we can't have I'm waving my hands around like it helps explain anything. We can't have the joints all aligned. They need to be overlapped halfway, so that if someone steps right at the point of a joint, what they're not getting is 4 corners. They're getting 2 corners and 1 long edge, and that's the strongest way to do it in terms of making sure that it's not going to subside or any of the things are going to yep. Oh, Jack Stack said you're cutting them anyway. Yeah, I could cut them into rectangles, but that would end up being a waste. And the thing is that I bought those pavers second hand, which means I can't get more. It was someone out in Warrandyte that was ripping up a pool lining area. Like they had a swimming pool and they pulled up all of the existing paving and they sold it on, I don't know where, can't even remember. I think it was Gumtree or Facebook Marketplace or something. So we bought all of those pavers and we've got piles of them in our driveway. It's enough to do that area plus some area out the front. We're going to have a landing at the front door as well. But if I cut them all into a rectangle to give them like the side ratio of a brick or whatever, we would lose it, and I can't just go out and buy more of the same. If I run out, that's it. I'm screwed. So, right. What was I going to talk about? I was going to talk about this thing, the 32 port version of the light switch IO board, and we're going to look at some firmware in relation to that as well. Now, oh, Dodgy says I kind of like the diagonal, something a little different. Yeah, Toby says you could even do a border or some lines through it of a different material. So, yeah, so that's a couple of votes for diagonal. Now, it's got to be said that this is not a democracy, and I do not get to make the final decision either. But yes, I quite like the diagonal, but the straight alignment is really growing on me. All right, so I'm slightly off camera here because I'm just fiddling around with some stuff on the bench where I've got a Rack32 set up and a 24 port board, which reminds me, I discovered a mistake. Let's go to an overhead view. So this is the 24 port board which goes into the rack mount, and previously this was the largest version. Do I have any others here? I thought I had a couple of others lying here on the bench, but it seems like I don't. So I've got 8 port, 16 port and 24 port versions of this same board, and now I have a 32 port version of that board. So this is using every single possible IP address, oh not IP address, every single possible I2C address on the MCP 23017. So we've got 8 of them here, and you can see little resistor networks on here. So that's a, now that I've done the 32 port version, I am so glad that I switched to resistor networks from individual resistors. Because previous versions of this board had, for each one of these parts, there were 4 resistors. So there were 16 resistors on each side of each of the chips. And that's a lot of placements. Going to resistor networks combines each set of 4 resistors into a single part. In fact, if I had an 8-way resistor network, that would make that even neater. Maybe I should investigate that. I should find some 8-way resistor networks. All right, so, and yes, it is a little bit silly having the I2C address headers on this board because we're using them all anyway. It's not as if you can change the addresses on the board With the smaller ones, it makes sense, particularly with the 8-way boards, because you might want to daisy chain them, which means you need to be able to configure the I2C addresses by changing the jumpers. But as I've explained previously, the reason that I have the jumpers on the full-size board, even though it doesn't actually need them, I could just hard code the addresses on these, is because what I do is I have this board laid out in Eagle, and then to make the smaller versions, all I do is, and each of these blocks is one sheet in Eagle. So there is a sheet in the schematic which has 2 of the MCPs and all of the associated parts and these and the connector. So that is one logical block. That is without the end part. That is one logical block, etc. So what I can do is, it means that instead of having to maintain 4 different projects in Eagle, I only maintain one project. I maintain the full size one, which now is this one with 32 ports. And if I need to do bug fixes, like say I decided to change the capacitors or whatever, or decided to go to 8-way resistor networks instead of 4-way, what I do is edit that in the full size project, and then I regenerate the shorter versions. In the schematic, I just delete the sheet for that section, and then in the PCB, all I do is do a region select on this end of the PCB. I set my grid to 70 millimeters. I snap it left by 70 millimeters, and I'm done. I then have the PCB layout done for the short version. And then I delete it, snap it left, and I've got the PCB layout done for the 16-port version. So if I make a change in the large version, I can then regenerate the 24, 16, and 8-port versions in only a few minutes. I don't have to go and apply the same changes to every single one of them. So yeah, so the result is that on the 32-port version, I have to allow for these address headers because I need them on the shorter versions. Now there are a couple of things that I could do about that, and I've been debating. One thing is I've been debating changing these to dip switches instead of pin headers. And I even bought a heap of dip switches. I'm going to go for a little walk into my parts library. Where is it? Switches, dip 3-pos. Here we go. I bought a bunch of these with the intention of possibly changing this over to use dip switches. So yeah, this is part of my my part storage thing. I've got DigiKey and LCSC barcodes on there, and I've got a barcode scanner. So if I want to order more, I just go to the DigiKey site, zap that with a barcode scanner, and it pulls up the correct page for me. So these are 3-way dip switches, and what I could do is put a 3-way dip switch at each of these locations. And this is the other thing I was thinking about. I could put, okay, hang on. I'm gonna have to draw some diagrams for this because it's gonna be a little bit hard to explain by just waving my hands around. Now, this is a possible layout tweak. Where's a pen? Right here in the pen drawer. That's where the pens are, because that's the logical place for them. All right, so imagine we've got this dip switch, or this way. No, let's do it this way. So we've got a dip switch. I'm going to make it large, and it's a 3-way dip switch, and we've got pads and holes like this, and then we're going to have, what do we have? I'm just thinking about how this circuit works. It's got pull-up resistors. I won't bother with the pull-ups. Just imagine that. Which way around does it go? No, it's got pull downs. I can't remember. It doesn't matter. Anyway, what I could do is, if this is the footprint for the dip switch, you can see it's got the 3 pins on here, 3 pins top, 3 pins bottom, goes in like this. When you flick one of these switches to the on position, it shorts between those 2 pins. So it's 3 independent single switches. But you can also see that there is actually a lot of space under here. And it looks a little bit small on the camera here, but this is heaps of width. What I could do is put resistor footprints underneath this switch. So it would end up like this. So imagine that this is copper where I filled it in. Because what this would allow is on the smaller versions, like on the 8, 16 and 24 port versions, I could then populate that location on the PCB, so this spot right here, I could populate it with a dip switch and then it could be selectable. But on the 32 port version, with the exact same footprint on the PCB, what I could do is leave the switch off and populate that with a 0 ohm surface mount resistor, and it would effectively be the same thing as if that switch was closed, if it was in that position and closed. So then what I could do in the pick and place job is just specify the binary values for the address pins and populate the ones that I want turned on and don't populate the ones that I want turned off. So if that was A0, A1, A2, which have binary, well, they have decimal values of 1, 2, and 4, and I wanted this to be address, I don't know, address 5, what I could do is populate a resistor there and there, leave this one open, and that then becomes address 5. I can't remember what the base address is of the MCP, but anyway, you get the idea. So the point is that what I'd be doing is I could have a consistent PCB layout and have dip switches on the smaller boards and have populated 0 ohm resistors, or it wouldn't even have to be 0 ohm, it could be 1K or something, just some low value. In fact, I don't even have 0 ohm resistors populated in a pick and place machine. So what I would probably do is just populate them with whatever is the smallest value that I have loaded, which is like maybe 220 ohms. I've got 120 ohm. I think I've got 120 ohm populated because I use those for CAN bus termination. So yeah, just some low value resistor. It doesn't even matter. It would just be enough to overcome the bias on the the other resistors that are applied to the line. Anyway, yeah, dual footprinting. That's a trick that I learned years and years ago from sorry, what gonna make how many? What? Yeah, sorry, I was saying dual footprinting. I know many people have done it. It's a trick that I learned years ago from Luke Weston, who I think sometimes comes along to the live streams, but I haven't seen him for a while. Right. Yeah, Sion says, through-hole dip switches, why not SMD? Too much soldering. Yeah, so surface mount dip switches would be an option. The only thing is I'm a little bit paranoid about putting plastic stuff through my reflow oven because my reflow oven is crap. Well, that's overstating it. It's not crap. It's it works okay, but the temperature is not that even across the whole thing. And so towards the middle of the area of the zone, the temperature gets hotter. And if I run things like plastic connectors through it, they tend to discolor if they are in the middle of the oven. If they're at the back or at the front, they're okay. So yeah, I need a better reflow oven. Yes. Yeah, went with pin headers versus solder jumpers as not everyone would be comfortable soldering. Yeah, so that's right, Austin's Creations. Originally, these were cut track jumpers, and the other place that was originally cut track jumpers was just here. So this is the I2C pull-ups, and at the moment I've got pin headers on here, which is extra work for me, because originally this was just cut track jumpers with a join on them. So if you zoom in on a cut track jumper, it typically looks something like this. I mean, the shape varies obviously, but you end up with two bits of copper like this and exposed here so that you can solder onto them. And an open cut track jumper is normally like this, and then you apply a solder bridge, like a blob across here, in order to close it. But what I was doing was, for the pull-ups on here on the early versions, I had closed cut track jumpers. So there was actually a little track in between. And the idea with that is that you could use normally it's closed, but if you wanted to, you could use a scalpel and cut that track so that it became open circuit. And then if you wanted to close it again, you could just solder blob across here. And then if you wanted to open it again, you remove the solder blob. But anyway, so the thing is that this is nice from a manufacturing point of view because it's zero effort. What comes out on the board is just a feature of the PCB. And then if people want to do anything with it, then they've got to grab the scalpel and make a little cut, or get a soldering iron and put a blob across it. But I had several people in Discord say, hey, that's a real pain. I want pin headers on there so that I can just put jumpers on and off, because they didn't want to have to be using the knife and soldering across there. They wanted it to be really simple to change the address, or to remove the I2C pull-ups just like that. Just pull these off and you're done. So I caved, I gave into the pressure, and I put pin headers on here instead. And likewise, I think in an early version I had, or maybe I didn't, I can't remember. I think I might have had cut track jumpers for the addresses, and I had them set to defaults. So on the first set it would have been 3 open cut track jumpers. Here it would have been 2 open and 1 closed. Here it was open, closed, open. And if anybody wanted to change them, once again, the process was grab the knife, cut the track, or bridge with a bit of solder and a soldering iron. And I ended up going to pin headers because it's just easier for people, for the end user to change that. And yes, it's a lot of soldering. This is the 24-port board, and look at all this soldering. And it's even worse with the 32-port board. How many is this? I don't know. It's a lot of solder joints. So we've got 8, was it 8 8s are 64, 128, 256 plus 6, 12, 24 plus, what have we got? 6 8, so we've got 48 plus 52 plus 12. I mean, I've lost track of what numbers, but it's somewhere in the order of 300 soldered joints that I have to do to assemble one of these boards. So 300 hand soldered through hole joints. Yeah, that takes a while. Now for these connectors, there's no real way around it, because I don't think there is such a thing as a surface mount version of these connectors. There are, yeah, they all come in this sort of style. And I don't know that I'd want to run them through the oven anyway. I could use surface mount pin headers on here, but I'd still have to put them on there by hand. So I'd still have to get them and sit them in position, because a pick and place machine couldn't put them there. And then be very careful putting it into the oven that nothing on here moved. So yeah, there are probably some tweaks that I could do in terms of the ease of manufacturing. But, oh, I wonder if anybody has noticed a mistake. There is a silkscreen mistake on this board. So we've got here the 32 port version, which is the brand new one, it just came out. And let's see, has anybody pointed out the silkscreen mistake? Andy just said, I'm surprised I haven't included a prototyping area on the I/O board. Yes. Yeah. Now, Austin's Creation says, yes, having the pin headers while increasing labor does increase the ability of new people to join in and use the hardware. Yeah, and putting the pin headers on is not too bad. I'll show you what I've done for that. I've got some assembly jigs. So this is the header jig for the 32 port version. So what I did was I just got the regular PCB. This is just a spare PCB from that same thing. And then I turn it upside down. So I'm looking at the bottom of the PCB and then solder the sockets onto here, everywhere that the pin headers are going to go. And I've got rubber feet on it. So yeah, I'm sure you can guess what happens next. Basically, I just pull out some headers. This is not, this is not the real thing, but it's just to give you an idea. There's a 4-way pin header going into a 3-way socket, but so all I do is I have the correct headers, sit this jig on here and I populate all of these, and then I get the PCB and I sit it, whoops, upside down onto there, and the headers all go into the correct place, and yeah, it just sits there, and then I can just go along and solder it all, and then at the end carefully peel them apart, which unplugs all of the headers, and then the jig is ready for the next one. So yeah, I often make up jigs like this. It's really, really common for me to use PCBs for a project for other purposes, like making assembly jigs and making test jigs, like taking a blank PCB and soldering soldering pogo pins into it, using this as a mechanical mount for the pogo pins, and then doing the electrical connections onto the pogo pins. So by using the same PCB as the device under test, it means that you can be sure that all of the mechanical alignment is correct. Yeah, so reusing PCBs in other ways for your projects is a kind of cool labor saving thing. Now, has anybody pointed out that silkscreen error yet? I don't know. Right, no, I haven't seen that yet. I'm still waiting for the comments about the silkscreen error on this board. Now, base 14. Yeah, I'm working in base 14. What am I doing? What am I doing? Right. So, where was I going? Well, I don't know what else to say about this other than the fact that it's here. And that testing it is also a real pain. So this is one that I was just testing last night. I've only assembled a couple of these. It took me like most of a day to assemble 4 of these. So this is the sum total so far of these that I've assembled. 2 of them have been through the ultrasonic bath, which comes back to Austin's question. Austin's comment about needing a bigger ultrasonic bath. Yes, so these two have not yet had rework and the bath done. These other 2 have, which is why they've got the stickers on them now. They still need to be serial numbered, but they are yes. A couple of people have got the silkscreen error. Yes. It says 24 port. Oh no, I've got to do another revision of the PCB. Yeah, I don't know if I can be bothered putting a sticker over that. Maybe I should. It currently says 24 port on the bottom of that when it's actually the 32 port version. So when I do the process of starting with the full version and then cutting it down, I need to move the end in each time to reduce the size of the board, and I need to change the silk screen each time, and I screwed up. So yeah, This one says it's 24 port, which means it's 24 port plus bonus ports. You get some bonus ports on the end. Now, what am I doing? I don't know. All right, let's, that's right, I was showing you this. So this is how I test it. What I do is put an Ethernet patch lead into each pair of ports, and then the test program, which I can show you, but it may not be that interesting. Maybe I'll show it to you running. What the test program does is set the state of all of the pins to being inputs, and then it goes to the first pin and it turns it into an output, and it drives the state high or low. I can't remember which way around it goes. Oh, they've got pull-ups. They've got pull-ups on them. Yeah, so they're all high by default. And then it drives one pin low, and then in the test firmware it knows the matching pin for pin 1 here is whatever it is, pin 7. No, 7? Yeah, I think it would be 7, because the ports go 1, 2, 3, 4. So the matching pin for pin 1 is pin 7. So it then checks pin 7 and sees if the state has changed, and it also checks every single other pin and makes sure the state has not changed. So what that's doing is checking that it can drive and sense that pair of pins, and that there is no solder bridge that is shorting any of the I/O lines to any of the other I/O lines. So it's checking for short circuits and open circuits. And it then does that for every single pin through the whole thing. Like it goes to pin 1, asserts it, and then checks its matching partner. Then it goes to pin 2, asserts it, checks its matching partner. So the test process runs through every single pin and checks it against every single other pin, looking for cross connections and things. And yeah, it takes a while plugging in all of these leads. And then it gives me a pass-fail at the end, and if it fails, it tells me where it failed. Now let's run that. So this is a Rack32 that has got the test program installed on it. And I'm going to, yeah, let's have a look at both this one has already passed testing, but let's have a look at both a pass and a fail. What am I doing? Here, I need USB. Can it reach? Almost, you can just see it. Plug in USB, there's no power yet because I've turned off that port on the hub. And then I need a cable. Where will I get a cable? There. So I need to go from here to here. So now I've got the Rack32 connected by I2C to the I/O board, which has all of these big loop backs on it. I've got power coming from a bench power supply. I've got 12 volts on here, and that just makes sure that there is enough power to run Ethernet and all of the other things, which in this case we're not even using Ethernet right now. You can see just off the edge of the screen it's not quite plugged in. I can't move that board any further across because that's the limit of the USB cable. So I'll give it 12 volts, and it's now alive. So you can see we've got power on the Rack32. You can see we've got power on the I/O board. And let's go to, where's the test program? Do I have the test program still open? I've just switched over to Arduino, which is taking a while to open. Come on, where are we? Open recent. Test. And then I'm going to show you this. So this is my super dodgy test program. So this is the thing that runs the tests. It's got possible addresses for all of the things. It just announces itself, and it runs through tests. It's just a very simple thing. It's just a loop inside a loop, and some offsets to do checks for the matching pins, and some other stuff that doesn't really matter. Anyway, the interesting thing is if we open the serial monitor. Oh, hang on. I don't even have the USB port turned on. Here we go. Let's try this. USB on. And now I'm just gonna, you can't see this, but I'm just gonna press reset on the Rack32 and hope, oh, wrong one. There we go. So, oh no, it's running the wrong firmware. Which one is that? That one. Yeah, it's not using the right firmware. Let's load that with the correct firmware. Hopefully this will work. In the meantime, drink. A drinking game. I drink every time there is a compiler error. Now, what are we doing? Hate to have a dodgy cable during test. Yes, that has... and Austin says, should make a 3D printed jig to hold the cables, sans the retaining clip. I'm going to show you some stuff in relation to that in just a moment. Right, because that is a big labour thing. What am I doing? That's right, I'm looking at this. All right, so we've got... I'm just going to hit reset again on the Rack32, so it'll run the test. Scanning for devices, and so it's found all 8 of the MCP23A17s. It's taking a while at this point because there it was running through every single possible combination of all of those pins, and it takes a little while. I think there is a short delay in the code because it gives some settle time. Now, if I come across to here and I unplug this one, I'm just going to unplug that cable, which means we are now going to get a failure. Come back to here, clear the output. Now, the way it gives this output is not particularly useful on the failures. It kind of helps, but yeah, what we can see here is an error on these pin tests. So, and it's given me a test failed. So we've got failures on all of the pins on that particular port. So target chip 3 and target pin 8, and then it's matching against chip 3 pin 12. So what it's doing is it's trying to drive chip 3 pin 8, and it's trying to read it on chip 3 pin 12 as the loopback pin. And you'll see that there we've got the error on both ways. So we've got, you can see the match there is between pins 8 and 12, and here we've got the same error on pins 12 and 8. So it's once it's found an error on one of those pairs, it really should only report it. So ideally what it would do is suppress these errors, because those errors have already been reported between these ones. And it would be, and also what happens is that when I get an error like this, it's usually because there is something like a solder bridge on the resistor networks between 2 of the little pins on the resistor network. And that will be, let's head over to the microscope. So on a resistor network, it'll be something like a solder bridge. Where am I looking at on the board? Where? There. I was in the area, there. Okay, so it'll be something like a solder bridge between 2 of these pins on a resistor network, which will then cause a failure. And so then, based on that information that it's given me, where it says failure on chip 3 target pin 8, I have to look at the PCB, and often I end up opening Eagle to figure out which pin on the chip is actually that one that's failed. And then I go and look at it, and hey, there's a little solder bridge. But it'd be nice if this gave me a bit more information about exactly where to look on the PCB for the failure. All right. So the all right, the labor saving thing. Labor saving. Where is the box? I've got to grab the box with all the bits in it, because in here I have this, which is a bundle of cables all glued together. And I've just had problems with it. I was trying to use this for testing yesterday. Let's, no, not that one, that one. And yes, it's a whole bunch of hot glue. So this is patch cables with the little connectors snapped off, like the retention clips on the back are all snapped off. So what I did was got a whole bunch of cables and I plugged them into a socket so that the alignment was all correct. And then I just squirted hot glue in all around them and then waited for it to cool and then squirted more hot glue and kept doing that basically until this is like it's a pretty solid block. It's very strong and the alignment is quite good. But I've been having some problems. So let's just get rid of these. All right, so the time it's taken me now to undo those. I mean, that wasn't long, but you saw it took me a few seconds to unclip those, which is faster than putting them in. The idea with this is that you just go like this, and then you've got all the cables in place. And when you're finished, just go like that, and you're done. And it shouldn't matter which way around it goes. So you just push it in, and if I had 4 of those, I could set this board up for testing in a few seconds instead of like a minute or 2 of plugging in cables. So now that that is in, if we go back to the desktop and I'll clear this output, what we should have here is a pass. But let's just see what happens. Dodgy says, could you not make a PCB with those connectors on? What it needs is, yeah, see, I've got a failure there on target chip 7, which is towards the end of the board. There are, is it numbered from 0? I think it is. So if we go back to the overhead camera, so there is now a failure in here that we weren't seeing before, and it is because of this assembly. It's some connection in here which is not working properly. And maybe with a bit of wriggling or something, it would then work. But I just found that I have not been able to make, oh, it passed. Cool. But yeah, you can see the problem. If that assembly is not put in and wriggled in just the right way, then you get false errors. And when I was doing testing yesterday, it was just being really frustrating. I would unplug it, plug it back in, and I'd get an error on a different pin. And then, you know, you're trying to get all of the ports to pass when you've got that sort of uncertainty would be really frustrating. And the last thing you want in a test environment is unpredictability of the tests, and where the result of the test is not necessarily the result of the device under test, it's the result of uncertainty within the test system. So that's what I'm trying to invoke. Oh, serial mon is out of view. Sorry. So what I was trying to show, yeah, so it passed that time was the summary. After I had got that connector and shoved it in and jiggled it around a little bit. So it's a trade-off. If I use the individual patch leads and plug them in, then what I've found is that the leads themselves are entirely reliable. So that it makes the testing, it makes the result of the testing more certain because it's based on the performance of the board, not the performance of the leads and things that are plugged into it. So there was a suggestion, I can't remember who it was it Dodgy? Someone said, oh yes, Dodgy said, could you not make a PCB with those connectors on? So what I would need is a PCB mount version of an 8P8C connector. And I've never seen anything like that. I would need that in a PCB mount version. And the problem, I think part of the problem might be that there is not quite enough give in the movement of the connectors here. So when you're dealing with So if I just pull that whole thing out again, when you're dealing with individual patch leads, the patch leads can move relative to each other, and the position of the pins and the things in here are not being really dictated by anything else. Whereas when it's in a block like this, if there is a very slight misalignment of each of these connectors, one of them might be being forced into a slightly twisted position just because of the way it's mounted. And then when you put it in, one of these may be having like a bit of a marginal connection. So I thought that this was going to save me a whole lot of time and labor, and it turned out that it didn't. So maybe with some messing around, I could make a version of this that would be better. But for now, I think I'm just going to go with the patch leads. And also, I've got to say, this is a huge step up from what I was doing before. So with the very early ones, like the first batches of these, the way I was testing this, and this sounds ridiculous, but this is what I was doing, was I had firmware on a board. It was before the Rack32. I think it was running on a, what was it running on? An Ether 10, I think, or an Ether Mega. And what it was doing was basically running the same firmware as I used to use for my light switches. And what it would do is just be watching each of the inputs and reporting to MQTT. So I had a terminal open with an MQTT subscription. And what I would do is get a light switch with a short patch lead, plug it into the first port, and I would press button 1, 2, 3, 4 while I was watching the terminal, and I would see the events being published. And if there was an event published, then it was okay. And if there was no event published, then it meant that there was an open circuit. And if there were 2 events published, it meant that there was a short circuit to some adjacent channel. So it was reporting 2 buttons being pressed when I'd only pressed 1. So I would sit there and go 1, 2, 3, 4, pull out the lead, plug it into the next port, 1, 2, 3, 4, pull out the lead, plug it into the next port, 1, 2, 3, 4. It would take forever to test one of these boards. And it was subject to human error, because if I wasn't paying attention watching the terminal properly and I didn't notice that the number of publications to MQTT was correct, then I could miss a fault. So doing this method with this automated tester is so much better. The only downside to it is having to plug in all of these cables and then unplug them all at the end. So it's about continuing to optimize the process. And maybe if I can get some kind of connection onto here, then yeah, the alternative, another way to do this would be to have pogo pins with little cup heads that go onto the bottom of each of these soldered joints. But there is a problem with that as well, which is that what that would not do is detect a failure to solder one of these joints, because it would be testing directly onto the pad. It would be putting the pin on here, sitting over the top of the target pin, and probably making connection directly onto the solder or onto the pad here on the PCB. So if, for example, during assembly, I had screwed up and I had just forgotten to solder some of these, and that happens. Like when you're sitting there and you're working through this number of joints, there are things happen. Like you'll stop to grab a drink and come back to it, and then you don't notice that you've started further across and that there is a whole set of joints here that haven't even been soldered. The pins are there. There is solder on the PCB because it's like a hassle finish, which means that the surface on the PCB is silver and it already has solder on it. So at a glance, you can easily miss it. With an Enig board, which is a gold finish, it's more obvious because some of these joints will be silver where they've been soldered and some will be gold where they haven't been soldered. But on a hassle finish board, it is actually remarkably easy to totally overlook soldering some of these joints, and that will cause a failure. So testing by plugging things in means that we are testing all the way to the end point of the device. We're not testing at an intermediate point and bypassing part of the device. And that's a really important principle. You need to be able to test the complete end-to-end signal path. So what we're doing here is testing what ends up coming out of the connector, not what is on the pad that the connector is soldered to. So yeah, I could make up a test jig with 200 odd pogo pins, which in itself would potentially be a reliability issue, which makes contact to every one of these. And yeah, but that's not doing a proper end-to-end test of the whole board all the way out to the perimeter or the periphery or whatever it is, the external connections. So now this brings us to firmware, and so Ben, known as Sumner Boy on Discord, and Moin, and I actually don't even know Moin's identity, but like when I say identity, Moin is Moin's identity in this context. I don't know Moin's name, so I will just call Moin Moin. And other people have been contributing as well. So but it's really Sumner Boy and Moin who have been driving the firmware for the Rack32 and other things for the Open Extensible Rack system, and it is so cool. I've got to show you this. This is neat. What am I going to do? Power. Turn off power there. Isolate USB. I'm going to get this one out of the way, and I'm going to put that Rack32 aside. So this is the one for testing. I'll keep that one separate. And this Rack32 that I have over here, this is one of the E versions with the UFL antenna for the external antenna connection. So this one, yeah, we'll use this for our testing. So let's stick in 12 volts coming in. That's not live right now. What we have here is the SPI cable going to an LCD, and that is a very important part of the process. This is so cool. We've got Ethernet coming in, so that's plugged into my network. It's not live, so nothing's happening right now. And I can't quite stretch. Hang on, I'm going to stretch it. See this USB cable just on the edge of the field of view. I'm going to plug that in because I want you to be able to see what's on the console. There, okay. So let's get this into a spot that you can see it as well. Now, what Ben and Moin have done is really, they've almost made this like a, what's the term? They've made it like an appliance in terms of the way the firmware works. So I'm gonna just sit this in the field of view here. And, oh yeah, so the board here, I'm gonna plug that into the I2C header. So now we have, what we've got here is the equivalent, in fact, I'm going to change this. I'm going to take that away, and I'm going to plug in the other 32 port board. No, I'm going to show you something cool. I'm going to plug in a 24 port board to start with. Let's start with this. All right, so what we have here is essentially a light switch controller. We have the Rack32 with its network connection. We have the status display for the front panel, and we have a 24 port thing here that that we can plug light switches into. Now I'm going to grab a light switch. Where are light switches? Show light switches down there. Oh, I've got to get stuff out of the way so I can get to them. Things stacked on things. I don't like that. Not that one. Find me a light switch, not that one. This one I think will do. I don't know why it was in the box. Maybe there was something wrong with it. We're about to find out. Okay, so I've got a 2-button light switch here. And we've got a patch lead so we can plug it in. And I'll just plug it into, I don't know, port 3. Whatever it is, doesn't matter, whichever port. Okay, so what we have there is a complete light switch system, like you would install in your house. Panel on the wall, goes down through the wall, etc., back to some central location, plugged into the I/O board, which is connected to the Rack32, and the status display. Now, let's give ourselves some power. So I've just turned on 12 volts. This is now powered up. Turn on USB. We've got power on the light switch, and we've got a status display on here. Now, this is what happens by default. It just comes up with this. I'm going to peel this cover off. Satisfying. So what we've got here is the status display on the LCD, and you can see it's dimmed down after a few seconds. So it goes into like a backlight saving mode. And it, by default, this is with no changes whatsoever, no configuration changes. This is the firmware out of the box, exactly as it behaves. You plug it in to your network, you power it up. It uses DHCP to get an IP address, and this one has been allocated address .237 on my network. It is reporting the temperature on the board because there is an onboard sensor. So it's currently saying 24.5 degrees Celsius. I'm sorry that you can't read this. The text on this is very small. I wonder if I could stretch it to the microscope. No, not quite. So it's giving the IP address. It's showing the MAC address, which could be useful if you're setting up static allocations on your thing. It's showing its MQTT ID, which is derived from the chip ID. Yeah, it's showing the temperature, and you can see, well, you'd be having a lot of trouble seeing this, but it's got IP, and there's a little green light next to it, which means that it has successfully been given an IP. Now, for the MQTT, it's got two little red lights, which means that it has failed to connect to a broker, which it will do out of the box because there's no broker configured. But it is on the network, and it's at .237. So, oh, and also, you can see across the bottom, see this row of boxes? It has automatically detected how many ports there are attached to it. In this case, it's 24 ports, and it is showing the status of each of those ports. Now, if I press one of these, oh, you can see that it's woken up when I press the button. The screen has come alive, and when I press this first button, once again, you'll be having trouble seeing it, just in there. So I'm plugged into the second port across, and the second port across, if I press the button, you can see there's a little pixel that comes on that shows the top left, and if I press the next one down, it is the bottom left. So it is showing button 1 and button 2 being pressed on that port. So you've got a visual representation of what is happening with the light switches, which is really cool. So it shows that we're detecting it. Now, .237, this is the funky bit. Check out how cool this is. If we go to desktop, and what you're seeing here is the console. So this is where it has failed to connect to MQTT, and it's telling us its IP address. Let's just copy that IP address. You don't actually even need the console. You can plug this device in, and from the LCD you get its IP, and then in your browser you just go to that IP. Hang on, .23? Why did it? Oh, I didn't get the last digit. And look at this. All you do is you go to its IP address, and it gives you this. I just glanced across at the comments. Jack's Tech said, see my earlier comments, the retainer clip is actually mechanically necessary in an 8P8C plug to compress the pins correctly in the jack. Yes, that's a very good point. So the shape of the pins in, hand waving once again, the pins in the plug are a rectangular, they're a rectangular shape, and then there is a pin in the socket which is a spring, and it comes in at an angle. So when you insert the plug, the contact in the plug hits the edge of the spring in the socket and it deflects it, so that the socket is applying pressure to it. And in each of those little 8P8C sockets, there are 8 of those little spring fingers. And because of the angle, they're basically going to be trying to push the plug back out again. So when you push the plug into the socket, the little clip on the back of it latches it in place and it prevents it being pushed out. So JacksTech is absolutely right. In normal operation, if you do not have that retention clip on the back of the plug, it will not stay in there by itself. It needs something mechanically to hold it in. So perhaps if I did a version of this where I retained a clip, one clip on the top and one clip on the bottom, for example, that might be enough that I can clip it in and have it latch, and that might make it more reliable. So JacksTech, that is a really good observation. Maybe it's worth going, I might go to the trouble of making up another one of these and cut off 3 of the clips on each side, just leave one clip, and that way I can push it in and it will latch in place and hopefully stay in place. But still be easy to remove because you can just squeeze the tips. Right. So this is, and Austin has been working on this firmware, I think, as well. So, right. Where was I at? That's right. I was looking at this. So this is what comes up if you just go to the IP address that it gets off your network. And you can see that there are some things here you can't change. This is just reporting its own firmware version, 3.3.0 and short name, etc. So, and maker, which is used to pick the logo that is displayed on the LCD. And here we can configure the MQTT broker. So let's put in 192.168.1.111, which is my bogus test broker. Well, it's not bogus. It's a real broker. It's just that it's unauthenticated, and I use it on my local network for, it's just a Raspberry Pi running Mosquito. So I use it for just randomly sending stuff to it for testing anything that needs MQTT. I also have another broker which is running on my Synology NAS in a Docker container, and that is authenticated, and obviously at a different IP address, and that's what I use for my actual live infrastructure. And in this case, because this is my test broker, it doesn't need any authentications, but you can put in username and password here. You can put in a topic prefix and a topic suffix if you want to. I don't want to. And client ID. I'm going to copy that. So what I'm going to do now is let's go to item and we'll do mosquito sub minus h 192.168.1.111. Make it verbose. Let's just subscribe to everything for now, and then I'm going to, because I don't know the structure of the topics, basically I'm acting as if I know nothing here. So what I'm going to do is just filter for any publications. Let's make that bigger so it's easier to read. Any publications that mention the ID of this new device. And can I get this somewhere that you can see it? All right, I'm going to move, which way? That to there, and oh no, I'm not. What I'll do is I'll move that over, I'll put it up here, and move this over here. There, almost there. Cool. So now we'll be able to see anything that gets published to that broker. So what I'm going to do now is save the config onto that Rack32, and immediately you can see that on the broker what it's done is it's connected to the broker, and it has published Last Will and Testament, and it has published to the adopt topic, and this is part of the future plans for the OXRS system, which is also super cool. We'll get into that. So what it's done is it's published a whole lot of information about itself. It's basically saying, I am here, I'm a new device on the network, I am running this particular firmware, this is my short name, this is the brand, the version, this is my IP address, it's got a config as a chunk of JSON, and all that sort of thing. So it's just making itself known on the network that it's ready for adoption. And it's then published temperature 31. So you might be wondering why this is saying it's 31 degrees in the lab. It is not 31 degrees right now in this room that I'm sitting in, or 31.5, it's going up. The reason that for this high temperature, this is getting slightly off topic, but the reason that it's reporting a high temperature is that I put a temperature sensor on the Rack32 because I wanted to know how hot it got running in normal operation in like a worst case scenario. So I deliberately did not isolate the temperature sensor from any of the onboard heat generated on it. So what I wanted to do was see, for example, the effect of the heat from the linear voltage regulator. If the board is getting hot, I want to know about it. So this is not, the intention of the temperature sensor on a Rack32 is not to report the ambient temperature. It's to report ideally the hottest temperature that the board is experiencing. So I want it to be thermally coupled to things like the onboard voltage regulator. Because one of the failures that you see a lot in networking equipment that runs for years and years is things like electrolytic capacitors drying out over time because they sit there running at, I don't know, 40 degrees or something. And if you have something running at 40 degrees for 3 or 5 or 10 years, eventually it starts to degrade. And I wanted to see how warm these boards were getting. Ideally, what I would have done is put the temperature sensor right next to the voltage regulator. So it was an absolute worst case, and I was seeing the temperature of the voltage regulator, but without messing around on the board, it just wasn't neat in terms of being able to place it there. So it's a bit of a distance away from the voltage regulator, but it's still giving a reasonable representation of the temperature on the board. I'm just taking a quick look. Where is it? Where is the temperature sensor? Oh, it's over there. It's kind of near the ESP32. Yeah, it is a fair distance away from the voltage regulator. I could have done a better job than that. I could have stuck it closer to the regulator. But anyway, it's meant to be representative of the PCB, not of the environment. Now, where was I? Yes, so that's right. I was showing you how cool this firmware is. So out of the box, with this firmware loaded, you plug it into your network, you plug in the I/O board and the LCD, and you turn it on. It gets an IP address. You go to that IP address, you put in your MQTT details, and we're done. That's it. Like, there is step one. There is no step two. So keep with that open now. You can't see what I'm doing. But if I now press one of these buttons, I've just pressed the first button, you can see it has just published port 3, channel 1, index 9, type toggle, event toggle. And if I press the other button, it's going to say port 3, channel 2, index 10. So the reason that there are different numbers here, it's showing this is the third port on the I/O board, and it is channel is button 1, button 2, like pin 1, pin, well, saying pin 1, pin 2 is not strictly accurate. So I'll say button 1. That's why it says channel 1, not pin 1. So that's pressing button 1, that is pressing button 2. And you can see the event is toggle and the type is toggle. So if I, and it can do other detection types, like if I just press this and hold it, or is that disabled in this version of the firmware? I don't know. I'll try a double press. No. Okay, so this particular firmware doesn't have that activated, but the I/O library has the ability to do things like detect multi-press and long press and all of those sorts of things. But what we've got out of the box is publication of events. Oh, that's right. I was talking about the numbers. So it's got the port and the channel, and there's an index. So the index is like the numbered position starting from the beginning and just numbering all of the inputs all the way to the end. And that is usually easier to deal with than a port and then like an index within the port or the position within the port. Oh, okay, so Austin says, by default that won't be active, you'd have to send a retained config message. Yes, so the other thing is that this can be configured through MQTT as well. Now in the idea with this is that you do not have to edit a config file and re-upload the firmware. In fact, if we go into here, let's just get out of that. Not the test, we're done with the test. Okay, this is the firmware. So this is the actual firmware that is running right now. It is the OXRS state monitor firmware version 3.3.0. And what you'll see is that there is no config in here for us to change. There's an extra file which is logo.h. That's the encoded version of the little logo that gets shown on the screen. And there is the main program, but there is no config.h, which is what I often have in my projects. I usually break out the config values into a separate file, and then you've got to edit them. Things like changing your MQTT broker ID, address, and all of those things I normally do in a config file. With this, there is no config file. You plug it in and it gets its address, and then you go to that address, you give it your MQTT broker, it connects, and then you can configure it through MQTT, which is super, super cool as well. Okay, so Austin just said, also on the webpage, go to IP address/OTA. Okay, OTA, this will be over the air. Not found. Oh, maybe I've got an old version of it. So hang on, 3.3.0. What is the current version of that firmware? I am just going to go to GitHub and see if there is a newer version. It is quite likely. State monitor, USB state monitor, I think that is the one. It is version 3.3.1. Is that when OTA was added, Austin? I think it may be. Now, if I go to, let's quit out of that, and in here, let's live dangerously, really, really dangerously. Superhouse projects, OXRS, what is it? SHA, state monitor, ESP32 firmware. Is that it? It used to be called Rack32 firmware, but because that is, we don't want it to be specific to the thing. So grepMSI version OX, what have we got? Version 3.3.0, git pull. Let's grab that latest version and see what's changed. What have we got? Plus 2 lines. That surely cannot be the addition of OTA just with that. So let's go on to version 3.3.1. Now let's open up Arduino again, and we'll flash this with 3.3.1. Oh, I just noticed how lagging YouTube is. I just glanced across at my at the YouTube Studio interface, and in what I'm seeing in there is things that I was doing like a minute ago. There seems to be quite a lag. All right, so latest version of the libraries? Possibly not. All right, let's see. And there are a lot of libraries. I need to make a script for doing this. So cd Dropbox sketchbook, libraries. There are, the way this is set up, there are a whole lot of libraries for different purposes. So there's the Rack32 lib, which is the specific stuff for that hardware, like that target platform, IO handler, MQTT, LCD. There's the general API, there's, oh no, that's not even one of them. So what I need is a LOX. What am I doing? Yeah, oh, LD. No, what is the directory? L, no, is that it? Yes. I can't even remember my ls flags. So let's do this. What I should do is do minus LD1. Let's try living dangerously. For name in that do cd name git pull origin main cd ... Done. All right, watch me break my computer with a loop. Did I get this right? Okay, so got it up to date, up to date, up to date, up to date. That is not looking good because it looks like everything is already up to date. Ah, okay. Aaron says just go to GitHub releases and grab the latest binary. All right, let's do that. I did not even know there was a binary there. Okay, and this is going to be a silly thing to admit, but then, oh, what have we got here? Is this the rare? How do I install the binary? Revert move required schema insights. Where are releases? What's releases? There. 16 days ago. Ah, OTA is lowercase and the API is low. Oh, maybe it's already working then. Let's go to, hang on, do I have that window still open? Oh, seeing this just reminded me of something I wanted to talk to you about, which is a really interesting Twitter thread that Andrew Sonnenberg is posting, but we'll get to that. OXRS, this is the one I want. So it could be that it's just that. It is. All it needed to be was lowercase. The firmware is already doing it. All right. Okay, so what we can do is upload. In fact, let's do this. Let's go to here and releases. That. Assets. That. All right, I want to download firmware version 331. Go. Download. All right, so now I should have that in my downloads folder. And if I now go back to here and I go to choose file and downloads, you get to see what's in my downloads. What have I got? Not giving anything away there. What am I looking for? What am I looking for? OXRS. Oh. No? What is it called? OXRS SHA state monitor. Yeah, where is it? Oh, there. Okay. Not that one, that one. This should be the firmware. And now upload. Uploading. And we'll see if we can do a firmware update. I have no idea what it's doing now. Is it booting? Is it? Oh, yes. Upload complete, restarting. Haha, cool. And starting up. Let's just switch to the overhead view so you can see it. So it says starting up and it's just said version 3.3.1. It's a pity you can't see this LCD better. /ESP32. And MQTT, it's got an ID. It doesn't show it as being connected to MQTT yet, but if I press the button, it's detecting it. Oh, it's got grey next to MQTT, which I think means that it is okay. And when I press this, it flashes orange. So, back into, are we seeing it? Yes. Now, if we go back into here, it needs some navigation to get away from this without changing the URL. So we are now, oh, you can't see it. There we go. So we are now at version 3.3.1. It has retained the broker IP address because that's stored in non-volatile memory. And if we come back to my subscription here, we can see that when I press the button, we are getting the publications. So we've just done an update of the firmware using the binary, the published binary. That is really cool. So I am very impressed by what this firmware is doing now. That is really cool. Yeah, that is quite amazing. So as Aaron says, hats off to Ben and Moyne. They've done an amazing job. Yes. This has been one of the really cool things about this project is that I've been working on these boards and I did my own version of the firmware that made them work, and I've been using them in my own house for ages, but I'm not really a programmer. I just kind of hack stuff together. I got it working, but then doing that was enough to inspire people that really know what they're talking about to do it properly, and that is how we end up with firmware that is as cool as this. And yeah, that does things like show the state on the LCD and does all the over-the-air stuff. Austin says Christopher Aitken was a huge help with the HTML. Cool, so a big thanks to Christopher as well. Right. I was 0.1 versions behind. Okay. And thanks to Chris also, Aaron says. Yes. Anyway, this was the main point that I wanted to get across. Oh, can you demo outputs too? I actually don't. Just thinking about how I could do that. I don't think I have a board that I could plug in to demo outputs. What could I use? So, okay, just to clarify what Aaron is pointing out here. This board, when I did the original version, the use case was to connect light switches, and so I originally called this the LSC, or the light switch controller board, and a couple of people had issue with that. One is that one thing, I can't remember who it was, but someone got really annoyed by the fact that it had controller in the name, because it's not controlling the light switches, it's reading from the light switches. It's not a light switch controller. So I changed the name, wrong camera once again. So I changed the name so that it's 24 port I2C RJ45 breakout. And that name change is also reflecting the fact that this is not just for inputs. So in the circuit, there is a 10K pull-up resistor on each of the inputs, on each of the I/O lines, and there is a 1K resistor in series with it, which is like a protection thing. I won't go into that. But the point is, it is set up so that the pins are biased high with the 10K resistors, and they have a resistor in series with whatever is connected on here. So it's optimally set up for using light switches connected back to it. But it is not just for inputs. You can also set the pins on the MCPs to be outputs, and you can drive. So instead of just reading inputs of things plugged into this, you can use all of these as outputs, and you can then drive other things. It could be switching relays with a relay driver board or whatever. The point is, this gives you a huge number of I/O pins. You do have to keep in mind that there is a 10K pull-up on each of the pins, so by default the output will be high. and that could be a safety issue in some cases. If you've got this connected to something that makes something move, you have to think about this a lot if you're like in robotics sort of projects. You have to consider the default behavior of things, and like in a power up state, for example, if you power this up and the processor fails to boot, or it takes a while to boot and it leaves all of the I/O pins in their default state for a while, if their default state is high and being high makes something move, that is a safety issue. But you do have all of these pins as either inputs or outputs. So you probably wouldn't use this specific board. It's I don't know why, but yeah, maybe there'd be situations where you would want to, but you probably wouldn't use this specific board for driving outputs, just because the AP8C connectors are not the most convenient thing in the world for plugging into something at the other end. But you could do it. So one of these boards could be used for driving, how many is it? Well, in this case it's 24. In this case it is 32, and there are 4 exposed I/O pins per socket. So you could use this for driving 128 outputs individually if you wanted to. And the firmware supports that. Now, maybe that's a topic for another day, but yeah, it is actually more flexible than it even appears at first. Yeah, hacker relay. Yes, Gorilla AU, teamwork makes the dream work. Yeah, so I am really happy that people are running with these and working on firmware and other boards and things that all interoperate with this system. That is so cool. Now, what was I going to do? That's right. What I might just do is just pull up some firmware, even though I don't have it running on here. Let's, Philip says, John, I'm into model trains. These boards could be very handy for my I/O requirements. Yeah, they would be. Yes. That is an obsession that I had when I was younger, and it is a potential black hole that would suck up all of my time and interest and attention. So for years I have resisted it. I used to have a really big N-scale system, and I still have lots and lots of N-scale stuff in boxes up in the ceiling. I ended up selling a whole lot of it at a swap meet many years ago, but I still have a lot. Yeah, if I had time and money and space, that is an obsession that I could totally get back into. But I know it's like some people fall into the trap of gaming, and it becomes something that they do every possible moment to the exclusion of everything else. I know that if I started messing around with model trains again, it's the thing that it would take over everything. I would just be obsessed with building stuff, particularly with the tools and the skills that I have now compared to what I had back then when I was doing it. Like, so I used to do things like brass turning to make parts for making like model steam locos and things like putting a bit of brass rod into a drill and using files and saws to shape it to make like a blow-off valve to go on a steam loco. And so tiny little blow-off valve made out of brass. Anyway, I used to love doing that stuff and just creating things physically and crafting them. But now with things like laser cutting and 3D printing and yeah, all of the and CNC machining, the stuff that I can do now, I've got to resist that temptation. I will not get back into model trains because I wouldn't have any life outside of it. Henrik says, You should make an I2C relay board rack mount. Yes, that is a good idea, and there are other boards available. Something I should point out is that I am not the only one making boards for this system now, which is kind of what I was getting at earlier. There are people like Austin who are building boards, and who else? There are a few. Let's have a look. I don't know. I actually have not even looked at the OXRS site for ages. Oh, which is terrible. What have we got? Add-on display. Oh, let's have a look in hardware and see what's here. Oh, I haven't even seen this. Ooh, who's making this one? Austin. Nice one, Austin. So here on oxrs.io, we've got a section of controllers. So let's just do a quick look down through here. We've got the Rack32 that you've seen. That's an old picture. I need to do one because this picture was actually taken before I had even received any of the PoE regulator modules. I had no idea if they would work or if they physically fitted on the board or anything. So this was a prototype when I was doing early testing. I need to take a new photo and update that. And I didn't even have a header because I hadn't tested the SPI for the OLED at that point. So the room 8266, this is interesting. So I guess that's the I2C header on there. And there is a big 5-pin thing on there, which I guess is a voltage regulator. Oh yeah, this will be the, so Austin really likes this switch mode regulator. The what is it, the 2985 or something? I can't remember. So there's an inductor there. This will be a switch mode regulator, and it's got the footprint on there for the PoE regulator as well. So we've got Ethernet on the front, and is there USB or anything else? Is there a header for programming? I can't quite see. But anyway, I am learning about the existence of this board right now. I hadn't even seen this. This is cool. Nice one, Austin. I'm going to have to check that out. So we've got the for input devices, we've got the I2C RJ45. So we've got an 8-port, 16-port, 24-port version. And I need to replace these with pictures of the real boards, and also add the fact that there is now a 32-port version. Output devices, PWM controller. So I2C interface. This is another one of Austin's boards. So we've got the I2C headers here and here so that you can daisy chain them, and it's got a header here so you can set the I2C address, and then it's presumably these are PWM drivers. What have we got? 16 channels, doesn't say what it is. Yeah, cool. PWM controller. Nice one, Austin. And smoke detector. So bedrock media, yes. So James is also working on boards. So this is the smoke detector board, which you could use if you wanted to be able to interface with smoke detectors. I think it does power to the smoke detectors. I don't remember. I'm not quite sure what the... oh, there's a wiki link. Let's go and check that out. Privacy error. Let's go to it. The certificate has expired. But, okay, so there is a... yeah, anyway, a whole lot more information there if you're interested in that. That is cool. So James is working on that one as well. Shields, a Rack32 KNX shield. So this is an add-on for the Rack32 that just provides a KNX interface. And this was done, so I think Frank designed this one because Ben is using KNX in his home automation system, and he wanted to be able to interface with it. So this board sits on top of this board, and it uses this set of I/O headers up here, and it sits onto the I2C header here, and you can and into the LCD thing here. So it passes through the LCD connection, and it uses the I2C connection. I think that's the way it works. Maybe it doesn't use the I2C. I don't know. Anyway, KNX. Cool. So I am sure that there are other boards that could be added into the hardware section on the OXRS site here. But yeah, I need to, like, everybody else has been working hard on this and I've been totally ignoring it, and I'm really sorry about that. I need to actually put in a little bit of effort and help out. Add-ons, accessibility. What have we got here? AC smart switch. What is that for? Oh, Austin working on a custom tower controller. Oh, right, yes. And displays, what have we got? IPS display. Oh yeah, I need to do some, so this is the 240 by 240. This is sort of an incomplete page about this. So this display is also available on this breakout, which means that it can be mounted and then just plugged into the controller. And switches. So we've got Austin's AC smart switch on here, which is one that I showed on the live stream a while ago, which is, yeah, it's a really, really cool project. I won't go into that, excuse me, more right now because, yeah, I've showed a fair bit about that in the past. I can't remember how long ago it was, but if you're interested in this one, this is a very cool project. Check out the live stream, which is where Steve came to live with me in that same live stream. He was in the box with the smart switches and the USB hub. So, where are we? What is the chat doing? What is the... Austin says, oops, that one has the wrong name. Yeah, that's... where are we? Hardware. Smoke detector? There was one here that said it was I can't remember. One of these. The PWM controller. Maybe. Yeah, one of these had the wrong name on it. Anyway, so yes, I am sure that someone, possibly James, had been working on an output board, an output driver board as well. So there are definitely more boards that need to be added into this list of all of the hardware modules that can be interfaced with this system. And there is definitely an output board, which I don't have. So I'm thinking about this whole thing of an output board. What is it? It's 11:44. It's heading towards the end of the 2 hours. And I do want to show you Andrew Sonnenberg's Twitter thread because it is cool. Use MOSFETs instead of relays, use with LEDs, and then you can add dimming as well. I'm pretty sure that James was working on a board. In fact, let's have a look at Bedrock Media. Bedrock Media Designs. Where is... yeah, I think this was it. Oh, this is, yeah, it doesn't have proper content in here yet. But there was the power distribution unit and universal I/O and relay 16. Is this it? That is an expanded version of my relay 8. And the relay 128 doesn't have anything in it. Sense, Arduino Uno. Yeah, oh, this is all on the wiki. I think there's more information on the Bedrock Media Design site. So let's have a look at, where would it be? Light switch controller. Let's just start in this category. Ah, okay, cool. 128 channel relay driver. That is a lot of placements. So this is basically an output version of my I/O board, but specifically designed for driving relays. And let's have a bit of a better look at this. So relays, I haven't actually seen this photo before, but yeah, so these are the MCP IO chips there, and a whole lot of screw terminals along here. So what I think he's got here is an option that you can either connect to the screw terminals, or you can use IDC connectors, just depending on whichever is more convenient. And it's got a whole lot of MOSFETs along here. So these are the driving transistors that turn the relays on and off. These are the snubber diodes that prevent against back EMF when you turn a relay off and the electric field around the coil collapses and causes a reverse voltage spike. So these diodes are to stop that. And where do you connect to it? Somewhere. Oh, down there. Okay, so here is the I2C connection that you would use for controlling stuff. So if you wanted to control 128 relays, you could use this board with a Rack32 or with Austin's, what was it, the Room 8266 to control them. But yeah, maybe what I should do is a version of an output driver board. And yeah, there was that comment in the chat about using FETs in setting it up with MOSFETs so that you can do PWM on LEDs. That would be really cool as well. Oh, James says check Discord. Okay, I need to catch up on Discord. Yes. Where are we? Oh, James says I'll chuck an image on the Discord. All right, now I'm just going to switch to the front camera for a moment and open Discord because I'm not sure what's going to open. This is the danger of live streaming. I have doxed myself many times. I doxed myself on the last live stream or the live stream before. I can't remember, one of them. It was one where I was showing orders. Yeah, it was the one where I was ordering on AliExpress and it showed the delivery address. And that was not such a clever idea. So I had to go back and edit the live stream after it had been live to try to blur it out. Come on. Getting into Discord. All right. Where is it? Is it in general? The DIN module for the RJ45 breakouts. Okay, here we go. Hang on, I'm gonna switch to Discord, switch to dashboard, switch to desktop so that you can see what's going on here. And we have, ooh, this is pretty cool. So this is a DIN rail mounted board, and I know this is probably quite small on your screen, but you can go and check it out yourself. Hang on, open original. Let's have a better look at this. So it's got those, I think they're 3.81 millimeter pitch pluggable terminals. Let's open, I'll close that one for now. Back to Discord. And this so James said this is the DIN module for the RJ45 breakout boards. Aha. Yeah, cool. Okay, so what you do is you use the RJ45 breakout board in the rack, like in a rack mount, and then have the RJ45 connector going from that into this socket, and then this can control things, turn them on and off. So that is quite cool. That is really interesting, James. Thanks for sharing that. And it's got some clever construction here. What you can see is that there is this PCB mounted inside the DIN rail enclosure, which is, so that PCB will be perpendicular to the DIN rail when it's mounted. The DIN rail goes through the part of the clip here. This PCB sticks straight out from the DIN rail, and then you can see there is another PCB up here in the corner at right angles to it, and it's mounted on this header, and it looks like it's soldered in here as well, probably for mechanical stability. So the electrical connections are passed through on this header. It's mechanically stable because it's soldered in here between the two boards. And then there are buttons which are exposed through the front. So let's just jump back to another view. Open original. And I'll jump back to another view because I want to see all these pictures because these are cool. This is nice work, James. And zoom in on all of these. All right, so on the front of it, you can see that the buttons are exposed there through the front panel. And those are the buttons that are on this bit of the PCB here. And if we look at the other side, we've got the RJ45 socket and the switch. Yeah. Oh, Jack Stack said, looks like a web relay. Yeah, except it's not, because this isn't actually Ethernet. This is being used for GPIO connections coming back to the breakout board. So what this will allow, so presumably this module combined with one of these would allow you to control relays in the switchboard. This is a pretty neat solution. Very, very interesting. Henrik, I don't understand this question. Henrik said, where is the light I suggested for you? I mean, how long you have to wait more? Send us a question. I sent a question in support mail. I wanted to show some PCBs. I don't remember that. Sorry, Henrik. I get a lot of email. A lot of email. I don't even get a chance to read most of it. Yeah, this would be getting a little off topic now. Last time I checked, I think I had something in the order of 50,000 unread emails. Yeah, it was, it's not pretty. But this is pretty. This is cool. Thanks, James, for sharing that. Now, oh, Henrik said, and I mean, where is the RGB garden lights you ordered? They would have only shipped a couple of days ago. I only ordered them last week. So, yeah. They'll be a while. They were coming from China, so it'll take a while. And I didn't order any special shipping method. It was just whatever the economy shipping is. So, yeah, maybe they'll be here in a couple of weeks. I'm not in a huge hurry for them anyway, because as you can see, we've still got to do all the paving. We've got to build the garden bed thing around the tree. Yeah. So, what am I doing? Okay, what I'm going to do is show you, I'm going to change topics totally and show you a really interesting little Twitter thread. Here we go. Now this is an ongoing saga. It is not over yet. So so if you want to find out what the most recent things are, you're going to have to check it out. I'm going to chuck this into the chat. So this is the start of the thread. And if you want to see interesting PCB work, you should be following A. Sonnenberg. And so FemtoArduino, there is a whole lot of backstory to this. I'm not going to go into the whole backstory of who the players are and the FOMU project and the BOMU and that sort of stuff. But yeah, there's some really cool work being done here. The backstory of this is not the point. This board could be anything. But FemtoArduino asked Andrew to help out with troubleshooting a prototype of the BOMU. And this is a 6-layer board with multiple levels of blind vias, or vias, whichever you prefer, and figuring out why the prototype didn't work. Now, for context, let me show you the size of the board that we are talking about here. I am going to, because I have a FOMU here, which is not quite the same thing, but it's the same size. So this board that I'm holding, this is a FOMU, which is an FPGA based board that fits inside a USB port. And just for fun, let's have a look at how friggin' small this thing is. All right. How do I get it? Where's the microscope? All right, I'm gonna have to zoom the microscope out a fraction. Zoom out and focus and a little bit dimmer. Okay, so I'm just moving it with tweezers here. So this is the PCB that we're talking about. And these parts, I think, are 0201 parts. There's a couple of QFNs and things on here. So these are my enormous fingers. I'm trying to get my fingers under the microscope to move it, and like the board disappears. It is, it is really small. And you can see on the other side, it's got the connections that are used to, so this plugs into a USB socket, and the whole thing disappears into the socket. And in fact, it's so small that to fit in the socket, it needs a little plastic thing that goes over this to make it thick enough. And then it's got touch sensors on here. So these connections up here are touch sensitive, and then it can communicate with the host computer. Anyway, I'm just going to see if I can get it on my finger for scale. Move that up and got to find where the, come on, where is the microscope? There it is. Okay, so that's just sitting on my fingertip for scale. This board is small. All right, now all of that was just to give you context for what follows in this thread, because it is kind of bizarro. So that tiny little board, what Andrew has done is sanded the board down, and it's a 6-layer board. So sanded the board down to expose the copper on the first layer. So this is the top layer, and you can see the pads there where the where parts are mounted. So you can see like there would be a part across there between those two pads. You can see the BGA would be mounted on here, and these are the pads that the BGA mounts to. And in the middle, you can see there's a nice big ground connection. There's a whole bunch of balls on the center of the BGA that go onto that ground connection, which links out through here to this polygon pore, this ground pore. And so, oh, and this is the other side of the board. Now, this is a prototype for a new version that they've been working on, and the prototype was misbehaving and they couldn't figure out why. And so Andrew was helping to look into it. And now there are blind and buried vias on this board as well. So blind and buried vias. Let's explain what that is. Get rid of that. If we look at a cross section of a PCB, then there, on a typical 2-layer PCB, there will be a layer of copper on the top and a layer of copper on the bottom. And if you want to join between them, a hole is drilled straight through, and then it is lined with graphite as part of the manufacturing process. I think it's graphite because it's conductive. And then I can't remember. My memory on this part of it is hazy. Anyway, there's a tiny little hole that's drilled through, and then it is lined with something, and then it goes into a bath to be electroplated. And so what happens is that you end up with copper plating running down through the inside of the hole, and that is what electrically joins the copper on the top layer to the copper on the bottom layer. So when you have a trace that comes in on the top layer and then it has to jump down to the bottom layer, it passes through the fiberglass through this via. And so normally what happens is that if you are laying out a PCB and you've got, it's just a two-layer PCB, so you've got front and back, it's really easy to stick vias wherever you want them because there's nothing in the middle to get in the way. But what happens if you have a four-layer PCB? So you've got another layer of copper in here, and you've got another layer of copper in here. Now the spacing is actually not quite like this, but we're looking at a cross-section here through the... So what would happen in 3 dimensions is this copper would actually come out around the hole. So there would be an easement around the hole so that there is no short circuit between this via passing through the board from the top of the board to the bottom of the board. Or in this case it would be layer 1 and layer 4, layer 2, layer 3. And so what happens is that you have a gap in the middle layer. There will be a circular gap where the via can pass through it, so you don't have a short circuit between the track here and this signal that is passing through here. So, thing is, in a really, really dense board like this is a 6-layer board that is like smaller than my fingertip, having a via that passes through all of these layers. So in this case we would actually have another layer here, we'd have another layer here. So that would be L2, L3, L4, L5, L6. So if you put a via between these two layers, you are interrupting all of the intermediate layers and you're painting yourself into a corner. It means that you can't run a track through that location in an intermediate layer because the via will be in the way. And so what happens with blind and buried vias, there are two variations on the same thing. With a blind via, say you wanted to have a link between this layer and layer 3, what you would do is you would have a via that is only drilled through here. So you've got connectivity between those layers, but you're not interrupting these other layers. You can have a track that passes through directly under the via on layers 3, 4, layer 4, 5 or 6. And so the hole only goes part way through the PCB. So that is a blind via. And a buried via is between intermediate layers. Say you wanted to join tracks on layers 3 and layer 5, you would have a buried via, which is a hole that is drilled between there and there, and it doesn't go through the fiberglass here or up here, so you can run uninterrupted tracks on either side of that buried via. So you can have a link between layers inside the PCB and you can't see it. If you look at the outside of the PCB, there's nothing there. There are just tracks here, there are tracks here. You can't tell that this via is even there. It's inside the PCB. So that is the backstory to blind and buried vias and how this little bit of work that Andrew is doing is so cool. Now, what you can see here is that he's found two problems. A blind via from layer 2 to 6 collides with a trace on layer 3. This is a design bug that slipped through DRC, which is design rule check somehow, and results in SW clock being shorted to a power rail. And if we come to here, you can see this is like an X-ray view version, X-ray vision version. You can see that there is a via here and it is colliding with this track somewhere inside the PCB. So you can't see it. It's totally hidden. And the problem is when you're working on a prototype like this, often there will be things that you need to patch, and that is typically done by using something like a scalpel and cutting some tracks and putting jumper wires and things on. But what do you do when the short circuit is an error inside an inner layer of the PCB? That's where this gets kind of crazy. So it says, so there's no polygons on layer 2 in this area. Okay, now he says, I plan to approach the region of interest from the layer 1 side, even though it's further away, because there are relatively few obstacles to navigate. So there's also a second short. The net on the circle pad is shorted to ground somewhere. So there is another short somewhere inside here that at this point Andrew hadn't been able to find. Now, this is, what Andrew did was cast one of these samples in epoxy so that he could then shave it down and descend through the layers of the board to expose it and verify that this is really what's going on. But in the meantime, okay, so this is a second short. So this is an area where a via is intersecting with another signal, and you can see here this blue signal that runs diagonally up through here is intersecting the edge of this via here. So this is all really just interesting detective work. So good news is we know where it is. He's found the short. Bad news is getting to it is not going to be fun. Now this is where things start to get a little bit crazy. So what he's going to do is attempt to patch this PCB on an inner layer so that they can get a prototype working and verify it. Now when it comes to doing things like patching prototypes, I'm fine with cutting tracks on the outside of a PCB and running jumper wires, but what Andrew has done in the past and is in the process of doing here is milling partway into the PCB to expose inner layers and then doing surgery on the layers inside the PCB in order to make this work. Aaron says, is DRC not supposed to identify these kinds of issues? Yes, absolutely it is meant to, but for some reason this one got through DRC. All right, so the description here, it says, I can come from the back side, which would normally require removing the WLCSP, milling down to layer 5, then cutting the via pad away from the ground plane. Coming from the front avoids the WLCSP rework, but I have to cut through the USB connector pad on L1, a power trace on L2, a signal trace on L3, and a signal trace on L4 before I get to the short, and then patch it all on the way back out. This is crazy levels of surgery. And all of that at the bottom of a high aspect ratio hole. Now, this is where are we? I'm trying to get down to some of the bigger bits here. So the easiest option is going to be start with a fairly large cavity. Okay, so when Andrew says start with a large cavity, it's 500 micrometers by 500 micrometers going through layers 1 and 2 and exposing layer 3, and it's going to be around a 325 micrometer deep milling operation. So then I know kind of where this is going to go. There is a problem coming up. Then need to go down another 1050 micrometers to reach layer 4. So think about the thickness of the PCB, and it is a sandwich of a whole lot of layers. There is fiberglass and then copper and then fiberglass and then copper. The copper is very, very thin. So what he's talking about here is using a milling machine to mill down through certain layers until he just touches the copper on the target layer that he wants to rework to expose it. So yeah, this is with the tiny little PCB mounted in a milling machine. And is that a camera or a microscope? I'm not sure. But yeah, you can see the tiny little milling bit here cutting into the PCB and exposing a little bit of the inner side, indexing off the top left corner of the USB D- pad so I can get close to the target location. So this is the tiny little cutter on the milling machine, and setting the location based on the position of the pad and ready to start cutting. So this is where the cut is going to be made down into the PCB to expose one of the inner layers. Now, this is where things kind of went wrong for this version. Initial exploratory cut, this was freehand with no backlash compensation, but the outline of the cavity at this stage isn't too crucial. The main cavity is about 480 by 60 micrometers. Yeah, I'll make it larger in the, I keep saying micrometer. Is that technically correct? Micrometer. I've been taken to task for saying that before. I'll make it larger in the horizontal axis. The angled microscope means it's hard to see the floor. So this is looking into the machined area. And you can see here, and just keep in mind how small this entire PCB is. This is the PCB I was showing you before, and this is the area that is being machined to expose inner layers. And overlapping the Gerbers on the optical image, we can see the cut position is dead on. The copper visible at the bottom of the mill cavity is the via pads, which are slightly larger than spec. So this is the photograph. So what you can see here with that gold copper sort of area, that's the photograph overlaid on top of the CAD view so that you can see the intermediate layers. So these are the layers that are coming through here to these locations where the vias are. And this is where things went wrong, because all the dimensions that were being done were based on a stack up of a 1.6 millimeter thick board, and this is actually a 0.8 millimeter thick board, which means that the Z axis, the depth of these cuts, was based on a board profile that had certain thicknesses, and it turns out that they were all wrong because Andrew was working from a file that was based on doing the stack up for a 1.6 millimeter thick. So this is an angled version looking into the hole that has been milled into the board, and it went too far. So, as I said here, so a milling operation that should have taken me from layer 3 down about halfway to layer 4 ended up going through 4 and 5 and almost hitting 6. More cool stuff. All right, so here's some more information from... So there are really two things going on in parallel here. One is taking the board which has been which has been set in a block of epoxy, and then machining that off in layers to expose the intermediate layers. And obviously the board is not going to work after that. It's a destructive process, but what it's doing is allowing all of the inner layers of the board to be viewed so that you can then discover if the short really is where you think it is. And the other operation is the one I've just been showing you with the milling machine. Right, so this is back to like grinding the face off the board basically and going down through the layers. So here's layer 6, via 5 and 6, and layer 5. So this is halfway between layers 5 and 6. And what you can see here, all these little spots, these are all of the vias that go between layers, and they are the vertical interconnects between those different things. And then the next picture is the next layer where some of those vias terminate. And there it is. So this is the short. So that thing right there is meant to be a via passing through and not making any connection to this big copper area around it. And you can see that this is where the DRC failed to pick up the intersection between that via and this bit of the copper. And there should be a gap right through there. That should be a separate thing like this and like this with isolation around it. This one should also have isolation. So this is where the DRC failed to pick up that intersection, and hence the short circuit. So this is what Andrew is trying to fix by doing that, that milling operation. More polishing via 4 and 5 and metal 4, so you can see we're getting down towards the bottom of the board here. There's not a lot left of it. You can see looking down through the fiberglass and all the layers. Really, really interesting stuff. I love looking at this because, firstly, Andrew has skill that I can only dream of having, but it's also really interesting to look inside the PCB and understand what's going on and actually see, because often when we order PCBs, we will have the design, we'll send off the design files. What you get back is a PCB with solder mask on it. It's got solder mask and silk screen. And apart from the exposed pads where you put parts on or through holes, the rest of it is kind of hidden from you. You can't see it. So seeing a view like this, where a board has been sanded down to the point where it's halfway between two layers and you can see the interconnects between the layers, the cross section of those interconnects, I find that really, really interesting. Yeah, it's like doing a CT scan or something and then like moving through the layers. Right, so more intermediate layers, more layers, and getting towards the end of the thread at this point. Oh, 3 hours, okay. Ooh, this is stuff that I hadn't actually seen yet because I think the last time I saw this thread, it was up to here, so 18 hours ago. He's still working on it. Back to the lab. So previously it was ordering stuff on AliExpress with John. This week it's reading Twitter with John. So here's a setup for another cut. I'm trying to fix a short where a blind via shorts to a signal trace. So this is the view of the cutting head going into the board, and this is the view showing where the short circuit is occurring. I think it's that one. I think it's that bit there. So the idea is to cut into the board far enough to expose this area of copper and then cut the copper across here to isolate the via. Yeah, I think that's what's going on here. These images are at 45 times as far as my stereo microscope can go. We've exposed the trace and can solder to it, but it looks like the short isn't broken yet. Okay, so this is looking diagonally into the hole, and you can see the edge of the copper just there, annotated so you can see the various structures better. Okay, what's going on here? Okay, so that bit of the track there is that bit in there, and that is the via, which is there. So it's isolating that from that. Looks like that's what he's trying to do. Top down after the next milling operation. Yeah, I haven't seen any of this part of it. This is all new to me. We're a few micrometers above the copper at each end of the trace. Can probably do the rest by hand with a scraper and scalpel. Yeah, that's ambitious. Okay. So here we've got a view, yeah, just another view into it, a few more steps. And so I think it's trying to isolate that in there. A bit of careful work with number 11 scalpel, and the short appears to be cleared, confirmed by continuity test. I need to do some more careful probing to verify I didn't break anything else, then reconnect the cut trace, and we're done with the easier of the two edits. Yeah, so you can see there, just in that area there, you see how that is now open. This via passes through the board. This bit of the copper over here has a clear gap. So that bit has been cut. And if we go back to this previous photo, you can see there that it has not been cut. So it's not isolated. So reconnect, cut trace. Yeah, anyway. This is all crazy, crazy stuff. That is... Anyway, I like watching people do this sort of crazy thing. Hang on. I've just blown way past my time because I was getting into watching the microsurgery on that PCB. I would love to see that as something like a live stream. See Andrew working on this. The thing is, they're doing this sort of work on a live stream. Doing any sort of work on a live stream is really hard. Not many people can do it. And I personally, I think it's because I don't like showing an unedited version of myself and revealing how little I know about things. If you're doing things off camera and then showing how it was done, it feels a whole lot less scary. And also a lot of it would just be me sitting there thinking about, how do I deal with this? And trying to come up with solutions to things. So it wouldn't be very interesting. But I wish that I could watch Andrew working on this. That would be fascinating. Seeing a live feed from the microscope as the milling operation is being done, that would be super cool. Yeah. Now, I am way over time. So I'm going to go. There was more I was going to talk about today. I've got more topics. I have so many more topics. The PCB conveyor project that I've been working on, that's been fun, and it's been fun getting back into doing a little bit of mechanical stuff as well, and many other things. But I think I need to call it for today. Sorry, I've still got Andrew's pictures up on my screen. Looking at editing intermediate layers of a 6-layer PCB that is so small that I have trouble holding it. This is one that I will answer. Dodgy said, Shelly Pro 4 PM update question. There is no update. I am kind of worried about this. I was really hoping that the Shelly Pro 4 PM would pass AU-NZ certification and I'd be able to install a few. Instead, I've heard nothing. I've sent a couple of follow-up emails to Altico asking about how certification is going, and I've heard crickets. I think it's time to prod them again. It's a couple of weeks since I've emailed about it. But yeah, it's what's the right word? I was going to say, I'm not really frustrated. It's not really disappointed either. That's the wrong word. I am excited for the Shelly Pro 4 PM and I hope it gets through certification soon. And the fact that it hasn't got through certification and I'm not hearing anything, it's just like I want it, and I can't have it. Aaron said 32 port available for sale now. Yes, it is, and I have now put it on the Superhouse site. So let's I2C. This should be the URL. So for those of you who are interested, it is. I think I set the stock level at some low level, like 2. I need to order more. Why is the Superhouse site not responding? That is not a good sign. Oh, I got there eventually. Okay, so I will drop the URL in here, and Peter says Steve should email Altico. Yeah. So this is, I'm just going to temporarily switch back to desktop. This is the page, the URL that I just dropped in the chat. And so I've now got it defaults to the 16 port version, but the 32 port version is there as well. And I set the stock level to 2. What did I made the price? 109. And I need to make some more 24 port ones, and I need to make some more. Yeah, I need to make more of all of them basically. Oh no, I've got 8 of the 16 port, so that's okay. And that's not a popular one anyway. Oh, 11 of the 8 port. Nobody buys the smaller ones. So the 24 port has been sold out, and the 32 port I've only just assembled some. So I need to assemble a bunch more. Haven't really been selling any Rack32s either. So what's been happening is kind of what I was afraid would happen, which is there was lots of excitement early on and people that were really keen for the Rack32, but it has a very limited audience. And all of this stuff has a very limited, it's a niche market. So what happens is that people are very excited about it, and then it is released, and then I sell like 8 or 5 or 8 or 10 of something, and that's it. I don't sell anymore, it just stops, because the people that are actually interested in it have then bought what they want. So yeah, I'm catering to a niche market here. But anyway, 32 port breakout, it's there. All right. So I am going to go and have lunch, and what else am I going to do? I need to assemble some more rocklings. I think I'm going to have to spend this afternoon doing pick and place and hand placement on parts for the rocklings, because it's it's a lot to go. I'm going to be spending a lot of time staring into that microscope over the next couple of weeks. All right. Okay. Now, there was another topic that I wanted to get into related to OXRS and infrastructure and the adopt thing. I'm not going to get into that. But if you cast your mind back to when we were looking at the console of the Rack32, and it connected to MQTT for the first time, and it published that message with all its configuration information, and it was published to the adopt channel. Hopefully there is some stuff coming in relation to that, which will be a user interface kind of similar to like a Unify interface, where you can add devices to your network and then adopt them into the system for management and control them. So that's what that's all about. Anyway, I won't get into that, or I'll be here for another 2 hours. 2.5 hours I've been here already. You're all tired of my voice, and I'm tired of my voice, so it's time to go and have some lunch. And I hope you have a great weekend. I think it's weekend for everybody by now. Every time zone in the world should now be on the weekend. So make it a good one, and I will talk to you all really soon. Now, how do I end this? I hit this. Bye.